With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, it is given that there are three identical particles ABC of mass m lying on a horizontal table. Now the light inextensible string which are just taut connect AB and BC, and angle ABC is 135. So this is the angle 135 degrees. Now there is an impulse J which is imparted to the particle C in the direction BC. Mass of each particle is m. We need to choose the correct alternative, and these alternative are regarding the speed of A, B, and C. Okay, we need to find what would be the speed of A, B, and C. Now in this case, what we can say that, for example, if A moves horizontally, because this string is horizontal and this is basically at an angle of 135 from this side. So we can say that if A moves with a velocity VA, okay, or we can call this velocity as to be V1. So since this string is to remain taut, that means VB should also move with a velocity V1 in the horizontal direction. Okay, but VB has also to move at an angle. Why? Because C is also moving at an angle with respect to this AB. So what we can say that B would be having two components of the velocity. So one is the horizontal component, and we can say that one would be the vertical component. Now the net velocity of C would be the total velocity of the resultant of the B. Okay, so this angle, whole angle would be 180 degrees. So this is 135. So this would be 45. So the final velocity of B, which would be in this direction, should be equals to the velocity of the C in this direction. Okay, now what would be the velocity of C? So we can take the component of V1 cos 45, and also V2 cos 45. That would be in the direction of BC. So we say that velocity of C, this would be equals to V1 cos of 45 plus V2 cos of 45, because this angle would also be 45. Okay, so these are the values. So we can say that VC would be equals to V1 plus V2 divided by root 2. And this would be the velocity, net velocity with which B would be moving. Okay, this is one of the case. Now, let's suppose J impulse is implied onto the particle C. Now, let us assume that there is a portion of the J impulse which is transferred here. Okay, so we can say that we just say that a portion of impulse, we can call this value to be J1, which is transferred here. So if we just draw our horizontal part of the string, so this is one of the ball, and this is another mass. Okay, now these are connected horizontally, so we just connect them. Now let us suppose the portion of the impulse which is transferred to this B is basically J2. Let's say this value is J1 or J2. We can assume any of the value. Now what would be this angle? This angle would be 45 degree. Okay, now what is basically impulse? Impulse means change in momentum. We say that linear impulse means change in momentum. Final momentum minus initial momentum. Now initially the system would be at rest, so we can say that our this impulse would be just equals to the final momentum. Now since A and B, they would be having horizontal and vertical velocity. A is having only horizontal velocity, let's say V1, but this is having horizontal velocity V1 and vertical velocity V2. This is our A and this is our B. So if we apply for our AB string in the x direction, so what would be the momentum? The component of the momentum, this impulse, it would be J1 cos 45. That means J divided by root 2. Cos 45 is 1 divided by 2. This would be equals to the final momentum. So A and B, they are moving with the same velocity. They have the same mass. So it would be 2 times m into V1. Now similarly, in the y direction, if we apply y direction, the same equation, momentum in the y direction equals to the this impulse in the y direction equals to the momentum, final momentum in the y direction. Now in the y direction, the component would be J sine of 45, but sine 45 is also 1 by root 2. So J divided by root 2, this value, this is our J. This would be the momentum in the y direction, which would be only due to the V2 velocity, which is only B is having. Why? Because A is moving horizontally. So it would be m into V2. Okay, now let's say this is our equation 1. Let's say this is our equation 2. So from equation 1 and 2, similarly, we can just substitute these two equations. We can say that V2 would be equals to twice of V1. Okay, now also what we can write? We can write that the value of the impulse. So this we are saying has to be, so here we have taken the value of the impulse to be J1. So we just write J1. This is our J1 impulse. Now from this expression, we can say that our J1, this would be equals to 2 root 2 m into V1. Okay, because J1 is the component which we are taking here. Okay. Now let us suppose if we do the same thing for our particle of the mass C. Let's say this is our C particle. Now if we just apply our this impulse equation for the particle C. So J momentum is applied, of which J1 is transferred to this system. So what is the net momentum which is transferred to our this C? It would be equals to, in this direction, we just first of all draw the direction. It would be in this direction. Okay, 45 degree. So it would be J minus of J2. Okay, because J2 it would be in the opposite direction for the particle C. Okay, now this is also making an angle of 45 degree. Okay, so what we can do, we can just apply our this change in momentum for our C in the in this direction. Okay, that means along B to C. So we can say that net momentum or J would be equals to PF. First of all, we write this equation. What is the net impulse for our C? It would be J minus J2. This would be equals to mass of C, which is m, into the velocity, which we have already calculated to be v1 plus v2 divided by square root of 2. Now we can already say that v2 is equals to 2 times of v1. Now if you make this substitution and also put the value, so this is our J1. This is our J1. Because a portion J1 is transferred to B, so the remaining would be existing for our C. So we can put the value of the J1. So J1 would be 2 root 2 mv1. So we put the value. So J minus 2 root 2 m v1, this would be equals to, v2 value is twice of v1. If you put here, so it would be 3 m v1 divided by root 2. Now from this expression we can get the value of our v1. So v1 value would turn out to be, v1 value would be equals to root 2 j divided by 7m. If this is our v1, what is v2? v2 is twice of this value, so it would be 2 root 2 j divided by 7m. This would be the value. Now what would be the value of our A? So A is equals to v1, which would be root 2 j divided by 7m. What is the velocity of B? Because it is having two velocity component v1, so it would be v1 and v2, and they both are perpendicular, so it would be v1 square plus v2 square in the square root. Now we already know v1, we already know v2. Now if you put the value here, so it would turn out to be root 2 j divided by 7m. And what is the velocity of C? So velocity of C, we have already seen, it is v1 plus v2 divided by root 2. So we already know that v2 is twice of v1, so it would be 3v1 divided by root 2. Now if you put the value of v1 into this expression, then it would turn out to be 3j divided by 7m. Now if we check which option is the correct option, first option, root 2 j divided by 7m, velocity of A, this is correct. Velocity of B, root 10 j divided by 7m. If we check, so it is root 10 j divided by 7m, this is also correct. Now velocity of C, 3j divided by 7m, this is also correct. The velocity of A, so this option is wrong, so the correct option are A, B and C. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.